What do you know about seagrass?
It's like seaweed, right? Or algae?
So what do you know about seagrass?
Absolutely nothing. I'm assuming it grows in the sea?
What do you know about seagrass?
Nothing. I would think it's grass in the sea or grows around watery populations, like a lake or something.
Obviously, there are some misconceptions and confusion surrounding seagrass, so let's talk about it. Unlike the algae pictured here that grow on rocks and sand using holdfast and stipes, seagrass is a vascular plant that grows in shallow water sediments using rhizomes and roots. These rhizomes absorb and store nutrients and help secure the seagrass in place. Here is a real-life example of what a seagrass rhizome looks like. These rhizome systems may extend across meadows and even allow for the asexual reproduction of shoots to travel through the rhizome and sprout in a different location. A meadow can form from a single plant in less than a year through asexual reproduction. Seagrass can also reproduce sexually through pollination of their flowers, similarly to terrestrial grass. Large pollen clumps are moved through currents onto the pistil of the flower, where fertilization then takes place. The three different types of seagrass in the Tampa Bay area are shoalgrass, turtlegrass, and manatee grass. Turtlegrass is the most common species of seagrass in Florida and is characterized by its flat, rounded-off leaves. Turtlegrass supports a variety of organisms, including 113 species of algae that attach themselves to seagrass leaves. Manatee grass is the second most common species of seagrass in Florida and is characterized by its cylindrical leaf blades and blunt tips. Manatee grass can withstand high temperatures and low salinities. Shoalgrass exists in conditions that are too harsh for turtle and manatee grass. However, turtlegrass and shoalgrass are commonly found together. Shoalgrass is characterized by its flat, narrow leaves and is known for being the pioneer species when restoring seagrass meadows. Seagrass meadows provide numerous ecological services that benefit the environment as well as society. Seagrass meadows, at the most basic level, provide a food source for herbivorous species such as manatees and green sea turtles, but a diverse food web extends beyond these more charismatic, well-known species. A single acre of seagrass can provide habitat for upwards of 40,000 fish and 50 million small invertebrates that we do not always see. These include countless microorganisms that cling to the blades, smaller crustaceans and shellfish including scallops, clams, shrimp, and crabs, as well as invertebrates such as starfish, sea cucumbers, sponges, and sea urchins. This diverse community of organisms results in a biodiversity hotspot that is beneficial for the environment as well as commercial and recreational fisheries.
Seagrasses can support in the billions of dollars for their fishery value, so they do support a wide variety of juvenile species that turn into adults that are important for fishermen.
Economic benefits extend beyond commercial fisheries as value arises from tourism and recreation industries as well. Florida attracted 126.1 million people just last year, making it among the top travel destinations in the world. Seagrass meadows are largely responsible for this, and they improve water quality and clarity, creating the crystal clear blue waters of Florida's coastal cities, including Tampa. Seagrass roots act like a tree, and they extensively distribute into and through the sand, trapping down what would otherwise be loose sediment that would cloud the water.
The water would become very, very poor quality without seagrasses.
Because seagrass provides a variety of ecosystem functions, its health is critical to the health of the greater ecosystem it supports. Observation, data collection, and restoration are important to ensure that seagrass continues to support coastal ecosystems and maintain productivity. An environmental indicator is a metric of how an ecosystem is responding to environmental change. This assesses how an ecosystem is impacted by the environmental change based on measurable data. When change is introduced in a seagrass bed, the response is a reliable indicator of deteriorating ecosystem conditions. This stems from two reasons. First, seagrass is located close to the shore and is directly in the path of pollutant runoff and reduced water quality. Secondly, seagrasses are often the canary in the coal mine. Seagrass meadows have quick degradation times and slow recovery times. Factors that affect seagrass health are light availability, temperature, salinity, eutrophication, coastal development, and physical disturbance.
With raising temperatures, seagrasses can actually die off, and so it needs to be closely monitored with climate change to make sure that we're seeing how seagrasses react to temperature, pH, and salinity changes in Tampa Bay.
These conditions may have anthropogenic or natural causes such as runoff, storms, and pollution. To use seagrass as an environmental indicator, the abundance can be measured by noting the extent and coverage. Aerial coverage is measured from a satellite, drone, or plane taking photos of the area. This method is commonly used because it can be conducted quickly and is non-destructive. While aerial coverage can help researchers determine the health of seagrass, it does not determine any causation. Linking seagrass health to abiotic measurements is crucial when determining steps to recovery. Seagrass requires a specific set of temperatures for growth. Optimal conditions for seagrass growth are a temperature range of 22.8 to 35.7 degrees Celsius, with the mean temperature of 30.7 degrees Celsius. Optimal conditions also include a mean salinity of 29.8 parts per thousand. Specifically in the Gulf of Mexico, seagrass has a minimum light requirement of 18% surface irradiance. Seagrass grows in a depth range from 0.3 to 3.5 meters, with each species of seagrass preferring a different depth. In Tampa Bay, there are several protected areas that include seagrass habitats. The Tampa Bay Aquatic Preserves include 4 aquatic preserves that cover 380,000 acres of land and water. The managers of the Tampa Bay Aquatic Preserves take data to monitor factors that affect seagrass health. While assisting the managers with data collection, students used a YSI, a LICOR, and measuring tape to collect abiotic factors. The YSI measured salinity, conductivity, temperature of the water, and dissolved oxygen. Photosynthetically, active radiation is measured using the LICOR, which indicates the surface irradiance and water clarity. In addition to abiotic measurement, the managers of Tampa Bay Aquatic Preserves also aim to educate boaters about prop scars left in the shallow water of seagrass beds.
Prop scars are very difficult for seagrass beds to rehabilitate on their own, so when a prop scar occurs, that can be present for a number of years afterwards, and even some restoration efforts by different agencies it becomes very difficult for the seagrass beds to fill in those areas, and the two communities on either side of the prop scar can become different due to that division between the two.
While the problem of prop scars persists, Tampa Bay has experienced far more complex issues in the past. In the 1950s, Tampa Bay entered an environmental crisis. Commercial dredging, coastal development, and urban runoff shifted the composition of Tampa Bay. Most notably, nutrient loading from wastewater treatment plants caused decreased water quality and eutrophication. In turn, light availability was inhibited for aquatic plants and algae populations boomed. Seagrass meadows, unable to receive adequate lighting or compete with growing algae populations, saw massive population loss. In the course of about 30 years, seagrass coverage in Tampa Bay almost halved, dropping from 40,000 acres to about 22,000 acres. To combat seagrass loss, scientific research was applied to policy. The Grizzle-Fig Act of 1980 ordered that levels of total suspended solids, biological oxygen, total nitrogen, and total phosphorus discharge from Tampa's wastewater treatment plants be below 5 milligrams per liter. Since the legislation was passed, nitrogen loading from point sources such as wastewater treatment plants has decreased from 67% to 13%. Overall, the level of nitrogen loading into Tampa Bay has decreased by a staggering 57%. As a result of decreased nutrient loading, Tampa Bay saw a 20% increase in seagrass coverage in just 20 years. Today, seagrass populations are at historic levels, making Tampa Bay one of only 2 locations to successfully restore seagrass meadows.
People always talk about turning back the clock, like, oh, we're going to put the bay back like it used to. We can't do that. We've got ship channels, we have these causeway approaches to the bridge where it's been filled in. The circulation in the bay is different. So maybe seagrass doesn't grow everywhere it did, decades ago, but maybe it grows in other places.
Therefore, it is important to continuously monitor seagrass populations and avoid becoming complacent with the success of past efforts. Broad influences such as climate change, water quality, and nutrient loading still pose a threat to seagrass in Tampa Bay and across the globe. Even today, urban stormwater runoff, septic tank systems, coastal development, and prop scarring continue to pose a serious threat to seagrass. Without proper management, seagrass meadows and the animals who call these meadows home could be lost forever.